Okay, ready, steady, go. Hello, Mr. Aaron, Mr. Ryan, are you right? Do you remember we talked about that?
Yeah.
What is that? Yeah, good memory. What is that?
Can't remember.
Can't remember. The N, the P stands for parent. The N is the node. What kind of data structure is this?
Binary tree.
Yeah, binary tree.
Let's go.
It doesn't have to be binary tree, okay? It's a tree.
I said graph.
Graph, yeah, tree is a graph. We talk about this SQL, structure query language, right? And we given a table, relational table, where N is the node, P is the parent. So in this case, we know a node have one parent, okay? It cannot have two parents, given this constraint. So we know it's a tree. It's a tree, it doesn't have to be binary tree, okay? So the question is what type to judge, to check which type of the node it is. How many different types do we have for a binary tree, for a tree? What kind of different? Three types. What are those?
Inner root leaf.
Yes, inner root of leaves. And on that lessons we talk about these two approaches, right? On the left here. So the strategy, as you said last time, I remember you mentioned a very fancy keyword called process elimination, right? So first of all, we check if a node has any parent. Here, this node 5 doesn't have any parent, so it must be the single root. Okay, it must be the single root. And then we check if a node. Now we check if a node is in somebody else's parent. This node 2 is in somebody else's parent. So what does it mean? So if it's somebody else's parent, then and it's not root, then it must be inner. Then the remaining is, what's the remaining? Remaining is the leaf node, right? So basically we use the if statement. If is a function actually in SQL. If is a function, the first parameter is a condition, a Boolean condition. So we evaluate if P is null, then the second parameter is the value you'll be evaluated when it's true, when the first expression is true. The third parameter is the value when the first expression is evaluated to false. So basically, the if function, put it this way: if something, then when it's yes, this is the yes value, and when it's no, this is the no value. So this if statement takes three parameters. The first parameter is a thing to check, right? If today is Friday. If today is Friday, then yes, we do a coding lesson. Otherwise, we don't do coding lessons, right? But on Sunday we also do the coding lesson. Okay, so let's say if another example. If today is Monday, then yes, because Eric needs to do the cello. Otherwise, Eric doesn't need a cello lesson. Okay, it's similar. Okay, so this one, look, the problem with this is. This big thing, right? This big thing is too much, right? For example, like look, there's if. Then let's say we have more condition to check. Then this becomes quite messy, right? Because look, I have to say if, then yes. Otherwise, and then I put another list if statement, and then there could be more condition to check. Then this whole thing becomes quite messy. So instead, we can use the case keyword. So case when. Okay, so the case N, okay, this is the block of statements. The case, when P is null, then is root, okay? Case statement, okay, so when P is null, then root, simple. When N is in this thing, right? In this thing, then is inner type, otherwise they leave. These two things are basically the same. So this one case is a syntax sugar for this if statement. Right? Let's say, why this is clearly better than that. Because we can add as many when statement as possible, right? So we can say case when something, then something, when something, then something. Then each line of code, we just put an extra condition and follow the logic. But this one is quite messy because we have if statement and else. We need to put more, then this becomes quite messy, right? Remember the decision tree, right? Decision tree. Okay, so these two things basically the same. This one is cleaner and neater because this is the syntax sugar and it's basically English, right? Case n, and you by looking at the code, you know what it means, right? Okay, when p is null, then this value. When n is in something, then this value. When something, then else, right? We process animation, simple. Okay, this is SQL. Okay, so we also after that we also talk about different type of join, right? The inner join, left join, right join, and outer join, cross join, right?
If a thing in
Yeah.
red, if a thing in red is like simple English, then a thing in blue is also English.
Yeah, by looking at this, what's the problem? Which one you understand better? Obviously this one, right? Because look, this one is not easy to follow the logic, right? If something, then this one. Else, then I have to do another check. If something, then this one. Otherwise that, right? Remember this decision tree. Right? So if this P is null, then okay, so that's the root. Otherwise, if the P is then this is inner. Otherwise leave, okay? There might be more branches there, so it's hard to look at the code and understand the logic. But this one is simple, right? We can say case when condition 1 is met, value 1. When condition 2 is met, value 2. And then this can be extended as much as you can. And else, right? If it doesn't fall in any branches we just said, then we give a else value, which is the leave node. Process animation, okay?
I
Okay,
just had a notification.
process animation. Okay, so this is the review, okay? We also talk about inner join, left join, right join, outer join, and cross join. Inner join, left join, right join, outer join, and then cross join, which is kind of a little bit different than the previous four, okay? Because cross join it's like a combination, right? It's the Cartesian product, okay? Okay, so this one, right, on the right, this will be a very good example of using the left join or right join in solving this problem. So the problem of this table, right? We want to get the information of which node is the parent, which node is not the parent, right? Okay, so this is the key thing today. I have this table. What happens if we join the same table twice? What happens? Like, let's say this is a tree table. Select everything from table tree. Left join, inner join, or right join, or outer join the same table. What happens?
Then you get every single number.
Okay, so let's say left join. Okay, select, this is a tree table, right? Select
Then
everything.
you should add, if you add all of those up, you should get the same thing.
The same thing, yeah,
And,
because
and multiplication up because
Look,
it's the
look.
same thing because it's commutative.
look, this is the same table basically, right? Two tables are the same. The left join and Excel, it's, Excel, okay? But it doesn't help. So now look at this. So we want to join this table, but in a reverse, kind of a reverse order, okay? So let's look at this. Select this thing, what does it mean? This thing. What does this thing mean?
Distance.
This thing means unique. If the n value has duplicate, we want to return only the unique version of it. So basically, we want to return one value, each different value only once. Okay, this thing t1.n. Case, okay, this case statement, right? We know that, right? We just talked about that. It's quite similar. However, look at this. We have t1, t2, which means the two tables, right? Select t1.n from tree t1, right? From tree t1. So that means that this table, we want to select from this table. First table, remember? Left join tree t2, okay? Ryan, sit down, please. Left join tree t2, okay? Look at this. We want to select from this table tree, but we give it the alias. Select from tree as t1. The alias keyword as keyword can be omitted. Left join tree, the same table, T2. Okay, so we are selecting everything from this table. Left join on itself, but we need to specify how do we join these two tables, okay? But here, T1.n equals T2.p. Remember, look this one, T1.n. If we put T1.n equals T2.n, then we are joining two exactly the same table, then it will return this, which is not useful. But we want to slightly change these two orders, right? So T1.n, we want to return T1.n equals T2.p. Okay, so in this case, what does it mean? If we joining two tables, then you possibly extend these two, okay? And then that will be n and p.
Okay. Let's
So
go.
on t1.n equals t2.p, so basically we can reverse these. We can reverse the second table columns because we want to make sure we connect these two tables. t1.n, the node's parent equals the second table's parent. Then why is that useful? Then we can check, right? When the first table parent, this logic is the same, right? The parent is null, then it's a root node. But okay, the second one, the t2.parent is null, then it's a leaf node, right? Right? Why is that? The t2.parent is basically saying that t1 doesn't have any children, then it's a leaf node. Otherwise, the root node. Okay? T2, because this is the second table. Second table's the parent is nothing. So this is the first table, right? Second table's parent is null. The first table's node should be equals to the second table's p. Okay, so this table's 2, for example, the node should be equals to the second table's p. t1.p, the first table's parent, right? This is easier, this is simple, right? We look at this. If the parent is null, then we simply return root, okay? Because that's certain, that's 100% sure, okay? Otherwise, we check this one. This is a little bit hard to understand. T2.parent is null. Basically, this is saying that, look, this is a little different, right? We check the leaf node first rather than the inner node, right? Remember the previous one, we check with the process animation, we check if it's the inner node. Elimination, right? We check the inner node, otherwise we return leaf node. But now this one, we return the different. We kind of slightly swap the logic because...
Stress over limb.
Okay, never mind.
Like...
T2.parent is null. Then we return leaf node. Because T2, the second table's parent, T2, the second parent, remember we slightly, reverse the two columns, right? We reverse the two columns. On T1.n equals T2.p. Remember, we use these to swap the order of the second table. So basically, T2.p, this is the saying that, if this node doesn't have any kid, if this node doesn't have any kid, then it's a leaf node, right? Okay. Look, don't be confused with this p, because this p is parent, but actually because we kind of like swap the order here, then we check if it's a leaf node. It means that if the t2.p is basically t1.n, if it doesn't have any kids, then we can determine it's a leaf node. Otherwise, determine it's a leaf node. Otherwise, it's a inner node. Okay. So similarly, this is the left join, but if we want to do the right join, what kind of thing we need to change? We change this t1 to t2, and when we change this T1 to T2, T2 to T1, and this doesn't change, T1, T2, this changes to left to the right, okay? And then this whole thing, we swap. On T1.p equals T2.n, okay? We kind of swap this, okay? And then order by T2.n. Do you get it? Okay, so one thing, why can we not use on T1.n equals T2.n? Why do we need to swap these, columns when we like kind of join these two tables?
Because otherwise, what's the point?
That's right, yeah, because look, we only have one single table, right? If we join only say we left join, or we inner join, or right join, it's the same thing because these two tables, overlaps. We joining the table on itself, we return exactly it, then we can't check, right? The thing here is N and P. We kind of like, duplicate this table, but we swap the columns. Okay, when we swap the column, that things becomes interesting because in this case, then we know, which children doesn't have any kid. Okay, then we know it's a leaf node. And since we already eliminate the root type, eliminate the root type, and we eliminate the leaf node, and then the rest is inner node, right? Okay, so can you tell me one difference? Last question. Can you tell me one difference between this approach and the approach we talk about today? That's it.
One's false and one uses if, one uses when.
What's so special about this? What's the strategy?
That one uses that thing. The T1. No.
So in terms one difference, can you tell me one difference between these two approaches? Just these two.
Well, yeah,
one is shorter than the other.
Yeah, I said one uses if, one uses when.
This also use when. I'm saying these two. These two are the same. On that day we talk about these two. This is the syntax sugar of that. And today we talk about this approach.
The left one uses process elimination.
The second one also uses process elimination. This is the same.
Process of elimination.
It's if it
It gives
are
it a
these two the
different
same?
order.
Different order. Yes. The last one is
That one says order by something. And
no.
That said order by something, and that says order by NAS.
This is ordered by the node in ascending order. For example, like 1, 2, 3, 4, 5. Okay, because we want to return the result. This is not the order I was talking about. The first
the
the
order of
process animation.
the order of the steps.
Elimination.
Okay, so the left one,
For
how do
example,
we?
if you're doing 1 plus 2 plus 3, one method is doing 1 plus 2 and then plus 3, and then one method is doing 1 plus 3.
Yeah, exactly. So for the left one, we determine the root. The left one, we check if it's a root. If not, we check if it's inner. And the remaining is the leaf. Can you give me the steps to check the using this approach?
So if they have no parent, then they must be root.
Okay, and the second step and the third step is
Yeah, but first like when, else, and that stuff. That's kind of like, so then, well, if it doesn't have any like descendants or something.
any descendants, yeah, kids,
Yeah.
then we call it leaf, right? Otherwise, it's look. This is the second step and the third step is different.
I
Then this one is what? Okay.
know.
And then that's just using the nested SQL subquery. Remember, like this one. This is subquery. But this one, we are joining the table, okay? So these slightly two different approaches.
Yeah.
Okay, that's it for today. Bye bye.
Bye.
Bye bye. Bye bye.
I need my socks.
Okay.